It's an articulated platform. The instruments here are the ones that are looking at in situ, measuring the solar wind, the magnetic field, the energetic particles, the cosmic rays. This is the magnetometer out on this long boom, and then there are two antennas connected to a radiator plasma wave instrument to measure the density of the plasma from how it rings. So here's that 1977 trajectory. Two spacecraft, because in those days you built two because they didn't live very long. And so our prime mission was a 4-year mission to Saturn by one spacecraft. When Voyager 1 flew by Saturn was, rings were like this, so Voyager 1 went like that, up out of the plane of the planets with no further encounters. But having done that, we could leave Voyager 2 in the plane of the ecliptic with the planets to continue what's called the Grand Tour. Uranus in 1986, Neptune in 1989. We flew over the North Pole of Neptune to an encounter with its moon Triton, and that's the reason Voyager 2 is headed southward, and Voyager 1 is headed northward. Here was Jupiter, huge, great red spot, of course, but what we discovered was that was just the largest of literally dozens of storms. These are all hurricane-like storms. That's about the size of the Earth, so these are major systems in Jupiter's atmosphere. And of course, before Voyager, the only known active volcanoes in the solar system right here on Earth. And then we flew by this little moon Io and found a moon with 8 erupting volcanoes, 10 times the volcanic activity of Earth, and we realized that our terracentric view of what's out there was just much too limited. On to Saturn with this amazing ring system, where many of the features you see are the result of the moons outside creating wakes in the rings. There's even a very narrow ring you can see here in this image, which is kept in place by 2 shepherding rings. And before Voyager, the only known nitrogen atmosphere in the solar system was right here on Earth. Then we flew by Saturn's moon Titan and found a nitrogen atmosphere that was in fact 60% denser than 60% higher pressure than here on Earth. And instead of oxygen, methane, natural gas, raining down on the surface. At least that was what we suspected, and that's what the Cassini mission has shown to be the case. On to Uranus, which is very bland. Its pole is here, its rotational axis is here, and it's on the side. Before Voyager, all the known magnetic fields that we know about, planetary fields, the pole of the magnet is up near the rotation axis of the planet because we thought it was the currents of the rotation that created the magnetic field. This magnetic field was closer to the equator than to the pole. So suddenly, our simple ideas of what made magnetic fields in planets had to be considerably revised and enlarged. On to Neptune. Only 1/1000th as much energy, and yet it has the fastest winds in the solar system. And it had a great dark spot, which has since disappeared. Probably because it does not have smaller spots that keep feeding it, if you like, which is what we think is happening on Jupiter. And there's a moon of Triton, which is a moon of Neptune. And again, before Voyager, the only known geysers in the solar system were here on Earth, active geysers. There's a moon. This moon is 40 degrees above absolute zero, and yet there were geysers erupting from its icy polar cap. So just time after time, we found our terracentric view just was not at all satisfactory in terms of our understanding. Since then, we've been on what's called the interstellar journey, which started in 1990 after we finished with Neptune, heading toward interstellar space. So the sun creates this huge bubble around itself. The wind from the sun, which is the solar atmosphere, blows outward at 1,000,000 miles per hour, creates this huge bubble. Outside, there's a wind from the other stars that blew up 5 or 10 million years ago, which has deformed that bubble into this comet shape. And we were on our way out trying to reach the interstellar space, the space between these bubbles that the stars create around themselves. And the exciting news is that a year ago, we now know that in fact we left the bubble and entered interstellar space for the